Well, hello. I think we'll go ahead and get started now. Dave, is it a good time for us to get started? You okay?
Yes, absolutely. Thank you.
Perfect. So welcome again to the Young Women in Technology event by Netapp. And thank you for hanging in there for us today and attending what should be a great session entitled "You Don't Have to Be an Artist to Work in Media and Entertainment." So I'm hoping you will enjoy it. Dave Frederick is our Media and Solutions Strategist, and he will be the facilitator for today's session. So I am going to turn it over to Dave, who is much better at this than I am, and let him continue introducing himself and the content to you. So Dave, take it away.
Great, thank you so much. And I'm really happy to be participating in this event. Part of my job at Netapp is to evangelize the media and entertainment business, both inside the company and outside the company. And so being able to talk to you and let you know that there's plenty of opportunities in the business for both people that have artistic talent and those who don't, and they're all valuable jobs, and they all contribute to making people happy. And that's one of the reasons why I love working in media and entertainment, and my colleagues who are in that business as well keep gravitating to companies and jobs that exist in this space. I'm going to just start the show. I'll give you an idea of what we're going to cover today. First of all, I want to just give you a feel for why media and entertainment is kind of a unique data model, and it has to do with the way media works, and also how complicated it is to deliver video and animation and those types of things in a coherent way that we can watch it, right? So that you've all seen videos online that buffer or stall, and we can't have that in professional media and entertainment. So there's reasons why that happens, and I think it'll be useful for you to know why that happens. I'll give you some ideas about where else digital media is used, so it's not just in entertainment, and there'll be opportunities for you to understand the potential jobs and careers that are available if you're not an artist, and that's the whole point of this presentation. And I also have a link for you at the end of the presentation, which is a great resource for researching colleges and universities that have media and entertainment programs. And so with that, we'll kick it off. Oh, watch for my thought balloons as they come up. They're intended to call your attention to some a fact or something about the slide that you're looking at. So watch for those, and we'll start the meeting now. So I hope that gave you some excitement and interest in, okay, so how do I do this? How do I get into this business? And one of the things that you need to know is sort of what is video, what is media, and the fact that it gets stored on the same type of storage that you would store Word documents or PowerPoint files is part of the challenge, because it is completely different than those types of systems. First thing to know about video is that it's temporal. That means it moves through time, and it can't move too fast and it can't move too slow. It has to move at the right speed, and that means that we need to be able to retrieve the material, retrieve the information from the computer, from the storage system to the computer in a way that it can play back properly so that we can understand what the video is about. And that means that there's a lot of coding and encoding, actually, where you encode a file and to make it so that it can be read in a sequential order that it's intended to be seen. And that creates a lot of complexity and also puts a lot of performance requirements on the systems that they're run on, both the computers and the storage system. And the other thing that's interesting about video is that it exists in two states in the computer systems. In one state, it's a stream. And in this case, this would be like what comes out of a camera. If you were to connect a camera directly to your television set, what you would see is what's coming into the camera at this, and you'd see it on the TV screen at the same exact time. That's because the data that is being encoded by the camera is being sent directly to the TV, where it's being decoded and shown to you. And you have no way of storing that information because you don't have anything to record it with in that situation. If you create a way of recording that video, then what you're creating is a file. And that's more like a bucket of water that you could pick up and carry around. And you could take it from one place to another. And in fact, you can copy it and you can share it with your colleagues, and they can work on it, and all the goodness that comes out of being able to work with files. But this when it comes out to a broadcast station, or when it's coming out of a camera, it's in this format. And then when it becomes a file, it's in this format. So those are two types of data that we have to deal with. All of you know that screens have been getting larger, but you may not realize the reason they're getting larger is because they have more pixels. So when we had HD, there was HD came out in 1999, around there, and it had 2 million pixels on the screen for an HD screen. And HD was pretty good until we saw what 4K was. And the misnomer about 4K is that many people think that 4K is twice as big because it's twice as wide as HD, but it's actually 4 times as big as HD. So now we're up to about 8.3 million pixels. As we move to the next phase, and in 2020, this year, 2021, we're already starting to work in 8K, and television sets will start to appear in 8K relatively soon. We're going to be dealing with 33 million pixels on the screen at any one time. Every pixel represents data, and it has to be transmitted to the screen in order to be seen, and that requires a lot of performance, and a lot of disk performance, a lot of network performance, and a lot of bandwidth. So this is one of the challenges that we have as the resolution gets higher. The other thing that drives the demand for performance is how many of these 8 million pixel screens are we going to be looking at in 1 second. So over the course of a second, when you watch a feature film that's projected from a film projector, it goes by at 24 frames per second. And that's about just above the minimum speed that you need in order to perceive smooth motion. Anything less than that, and it starts to look choppy. So, but when digital television came out, then we got a whole bunch of new frame rates that increased the number of frames that we see in a second. And as you can imagine, increased the amount of data that had to be transferred in order to show it. So all the way up to 120 frames per second. And this creates very smooth motion when things are moving quickly on the screen. One of the first opportunities people had to see 60 frame HD and 4K was the Olympics, because so much of that was in sort of high speed activity, and people wanted to see it very smoothly. Another contributor to the amount of data that needs to be conveyed is color. Now, if you take ink and you combine inks, usually it's red, blue, and yellow. And when you combine various combinations, you get different colors. But ultimately, if you combine them all, you would get black. Well, when you're talking about light, when you combine all the 3 basic light colors, which are RGB, you've heard that, red, green, blue, they become white. And so the number of colors that you can represent depends on the bit depth of the color space. So if you have every pixel that we talked about on that screen could be an 8-bit value for color, and in which case we can only represent 256 different combinations of the 3 colors. And you can see it doesn't give us many choices, and we can't get smoothly from one color to the other. There's no in between in places like this, between this purple and this lighter purple. It's kind of a hard edge. as we add bit depth, we add smoothness. So we get more different variations of colors as they go along. And finally, 16-bit gives you an almost seamless transition from one color to the other. So you have thousands and thousands of colors to choose from, and a great degree of nuance. But you also are storing more data per pixel, and that requires even more performance. So when you look at what I said, remember about the bucket of water, these buckets come in different styles, and it depends on what's in the bucket. So if we have something small, like an HD, relatively small, an HD stream, then that 1 hour of HD would be about 23 gigabytes of data. So what this chart is intended to show you is the relative size of how much data is required to deliver 1 hour of video in these different formats or bucket types. So for 4K, for raw 4K, just the basic out of a camera 4K, it's 741 gigabytes of data for 1 hour of video. And as we go to 8K, it's going to become 7.2 terabytes of data for 1 hour of 8K. So again, you see the challenge that the industry is under, just having to deal with the explosion of the amount of data. Think back to that Dreamworks video. They have over 500 million files that they have to deal with for every movie, and they tend to work on about 10 movies at the same time. So managing all that data and having that data be this big is really a technical challenge that takes a lot of work to overcome. So just like anything else, whether it's development operations and you're doing coding or you're doing project planning or whatever, there's a workflow associated with creating media. And it tends to fall into, sort of information in this case, ingest. It either comes from a camera, or it comes from a file, or it comes from some other source. We're going to edit that. So we're going to select the order of the shots and the transitions and the layers and what the audio is happening at the same time, and create some visual effects. And then it gets matched and re-recorded to the right format for delivery. That also includes subtitles and captions and alternative audio, and all those other things get added. And finally, it's delivered in the form of a DVD or Blu-ray disc, or it streams, or it gets compressed and put over regular television broadcast channels. I just wanted to give you an idea of this, because all of these are usually handled in one company. They do the whole process, but there are companies that specialize in areas of the workflow, and they work in conjunction with companies like Dreamworks to help them get their work done. So in editing, what happens is, now remember, again, we're talking about these big files, and they have to be played back in the right order. But what editors do is they want to create a program that shows you one shot for a while and then goes to a different shot, right? You see this all the time when you watch TV or YouTube or whatever. So deciding what shots come one after the other means that we have to be able to see the two shots and how they relate to one another, and where we're going to make that transition. Also, there's a audio to deal with, and there's lots of different clips that and shots that the editor is going to be looking at. So programs like this, there's probably half a dozen to a dozen different programs that people choose to do video editing. And in fact, most of you have a built-in video editor right in your Windows computer called Movie Maker that you can try anytime you want for free. So you can create your own movies, and that's many of you already do. So the other thing to keep in mind is that this is a huge development task to build one of these applications and work for companies like Adobe or others that make editing apps. So that's an opportunity for you to think about if you're interested in media and entertainment and you're in coding. VR, I don't know if any of you have seen VR or have VR at your fingertips, but editing VR is super complicated. It makes it much more difficult for the editor to visualize exactly what's going on while he's doing the editing, because the action is happening in his two eyes and 360 degrees around. So you have to make special accommodations to show the editor the entire scene. Here you see this gentleman and this lady are sitting next to each other in the boat. In the VR scene, the 360-degree view, gentleman is over here and the lady is over here. And then this wraps around you 360 degrees. So then what you saw in the Dreamworks video was animation. And animation is a little different than video editing in that animation is made up of a series of individual images that are played in a correct order to become motion. And that's why they can do things that we can't do in video. For example, they can create models or characters or scenes that can't exist in a camera, and then move those models scene by scene so that it creates a natural motion, and then that gets turned into a video. The difficult part about animation is each of these images are usually quite large, and you can't necessarily work in the best resolution that you want to all the time, because it takes so much graphics capability to turn this into an attractive scene. This is kind of a working level, medium working level scene where he doesn't have a lot of hair and there's not really any shiny spots. The background is kind of blank. So this hasn't been fully rendered. And but this would be the way a modeler and an animator would work with a character and create a scene and be able to move the camera around and move the lighting around until he's ready to render it. And we'll talk about rendering in a second. In fact, right now. So what rendering does is it uses the computer processors, or it uses graphics processors to generate how light would react with all of the materials that are in the scene. And this is for every frame of a video, of a movie. So it figures out, where is the light source? How does it pass through transparent objects? How do those transparent objects refract and reflect the environment around them? And also what happens when light bounces off a color, and when the ambient light of the area shines on a surface, and then where's the shiny spot depending on what the surface is made of. So you can imagine this is an incredibly complicated computational challenge, and it can take a long time depending on how much compute resources you have. So by using standard CPU cores like Intel, it typically takes about 29 hours to render one frame of content, of like Pixar quality content for a feature film. So obviously 29 hours is too long to wait for one frame to render for a 90-minute movie. And what they do is they create render farms that have hundreds of thousands of CPU cores all working on the same content at the same time. Recently, and by the way, I just call your attention to the fact that there's a whole industry that is about the language of 3D graphics and graphics modeling, and how that language gets embedded into chips to accelerate the process of animation. And so if you're interested in chip design or API languages and those types of things, there's a lot of companies that do that kind of work. Now, recently, especially from NVIDIA, has been working on what are called GPUs. These are graphics processing units, and they're designed specifically to render these types of images much faster. And it allows for higher quality images to be done a lot quicker. So this image is a 4K image, and it was rendered in 1 minute for one frame using 1 million GPU cores, which actually is only a few GPU units. The cores are tens of thousands of cores in a chip. So it can greatly reduce the amount of time that people have to spend rendering, and they get better quality. They also use GPU units for all kinds of high computational problems like AI, medical research, etc. So if you don't know about GPUs, it might be interesting to take a look at them, do some research, and NVIDIA has a lot of useful content on that. Compositing is another technique that people use to combine the 3D models with live action. So this is where you would take a video and then you could add 3D elements to that video. I'm sure you've seen movies that do this. And the 3D elements can move in the same way that the camera moved in the scene, so that you get the impact of, okay, here is this item that's in the middle of the room that these two guys are looking at. This is from Avatar, where the data is being shown to them as if it was right on their tabletop, right? So it has to move with the camera. It has to be the sized properly for the space, and that's all a very complicated task, but it comes out great when it's done well. So in animation, a lot of the work is all around movement. And how do you get movement to look natural? So animation programs use what are called bones or splines to create a skeleton for the model. And then the model itself follows the path that the skeleton takes. So when animators want to make something walk, they move the parts of the skeleton as if someone is walking, and frame by frame you end up with something that can walk, and all they had to do was say, okay, I want a left foot and a right foot to move in these patterns. And in this case, the dinosaur shows you, you can see his knee and his heel and all the other aspects of his walk, which only had to be programmed by moving bones in a particular location, and then the software took care of creating all the stuff around those bones, because the modeler had decided, okay, I want dinosaur skin and I want it to look like this. So I'll give you that could be a pretty tedious task, and is to move all those things so that they look natural. And you may have seen movies where the movement didn't exactly look like people walking or people moving around naturally. So motion capture is used to have people act out the motions that the animator wants to see, so that it physically matches what a human being would do. And they put sensors on the actor's body, and then, or performer's body rather, and then that transmits wirelessly to a computer that's gathering the data in 3D. So it maps the spots that all of these points on their body make over time, and it creates an animation sequence that they can then wrap a different character around, and it will move the way they want them to. So I have a kind of a unique example of motion capture here I want to show you. This woman is running down the line, right? Her job is to run down this line and jump on this box. Okay, so she runs along here and jumps on the box. And they captured the motion of her body with the motion capture sensors. And this was in order to create a commercial for Gatorade. And so I'll show you how this works. What you're going to see, and I'll turn this on in just a second. What you're going to see is an animation sequence of that woman running across the floor and jumping on the box, but not turned into a 3D model in a computer, but rather rendered by having drops of water fall from a mechanical release mechanism that creates almost like a rainfall that matches her motion. And it gets animated by the fact that the flashing lights flash at a regular interval. And that's what creates the motion in this next sequence you'll see. So I hope everyone enjoyed that. I found that pretty amazing that they built all that to just make one 30-second television commercial, but I think it was worth it. So now we'll take a little turn now that you kind of have a feel for the kind of work that's done in M&E and why it's different than regular other types of data and what we can do with it, and to talk a little bit about what if you're not an artist. Well, in all the cases that I've shown you, especially the animation cases, there is a code that creates these types of models. And it's really just a matter of manipulating simple polygons that can be created by a language. One of the languages was originally called Opengl, which is an open graphics language. And it has all the methods for creating a rectangle. And then you stitch enough rectangles together and you get a donut shape. And then you start to smooth those by increasing the number of data points for each rectangle, and it becomes a smooth donut, etc. So there's plenty of opportunities to work in a coded environment. And it's not just for entertainment purposes, right? You can do this for a number of different applications, and I'll show you those in a second. Another area in media entertainment that I think people forget about a lot is hardware development, and especially display technologies. You've all seen what's come along recently with originally plasma screens, and then LCD screens, and now OLED screens, and they just keep getting better and better and clearer. And there are many people who work on these, and they have to do with the physics of optics, as well as glass and lighting up and electronics that produce light, and color depth, and all those kinds of things that create a great image. Because ultimately, that's what this is all about in M&E, in media and entertainment, is producing the best possible image that we can. And these display technologies, these screens, are being used in more ways than just to make television sets. I'm sure that many that you may have seen The Mandalorian. Well, what you may not realize is the backgrounds in The Mandalorian that are shown in the scenes are not added later after the fact, and they're not real, but they're a giant LCD screen that's 20 feet high and fits 75 feet around, a 360-degree wall that is fed with images that can move or change as the director wants, and then they shoot that scene. And in this one, you see, the lighting technician is shining a light on the Mandalorian to make it look like he's sitting next to a fire. There's Baby Yoda there, just looking cute. And here's some lights up here. They're not going to appear in the shot. And so they can make an entire scene just by filling these screens with whatever it is they want to have show up on the scene. So tonight, when the new Mandalorian comes out, you can watch that and watch the backgrounds, and you'll know that they're all stored and served from Netapp systems. Okay, I have another video clip to show you about another way somebody's using LCD technology, and that's combining it with architecture. What you're going to see in the next clip is the front of a university in South Korea. It's their entryway to the building, and everything you're going to see is being produced by a flat screen LCD, basically a huge television set. So if it looks like it goes deep into the building, it doesn't really. If there's two doors there, you'll see the doors in the front of the building. But watch what they can do with an unbroken flat screen television. about that? That's pretty cool. So I mentioned that there's a lot of other industries that use graphics and use imaging. And, you know, many of these are something you would think, oh yeah, of course, I've seen this before. You know, you get these 3D walkthroughs of architectural environments. But this is incredibly useful. And there's a lot of companies that make software that do this. And there's a lot of people who model that do architecture in these applications. And you don't necessarily have to be an artist. If you like architecture, and you can create things like this by using the applications that are available, and the textures that you can choose, and the items that you see in the room can be provided for you, and you can design things that people can see. In medicine too, they use 3D imagery to identify certain characteristics of cells by having those be tinted different colors based on the cell structure, and then also by setting a value that will determine their height above the landscape, and that sort of calls them out and makes them easy to identify. Industrial design has been done in 3D for a long time, and you know, it's used quite frequently. So if industrial design or mechanical engineering is something that you like, you'll probably be using a CAD system. And finally, civic planning is another example of a way to visualize what an area will look like and be able to convey that visualization to other people in a way that makes sense to them, so they can see it even though it doesn't exist in real life. So as I promised, this is the website that you should visit if you're interested in schools that can teach film and video practices, and they include also technical approaches. You know, so if you're coding or doing other types of stuff around film and video, they offer these types of classes. And this is a nonprofit.org guide to affordable film and video degrees that you can get. I'm going to take a few questions in the time we have left. By the way, you should know that every movie that Dreamworks has ever produced has been done on Netapp. Netapp storage and data management systems. So they're a very good customer and partner of ours. So do we have any questions? Or am I going to read them? Okay, let me take a look here.
Yes, Dave, we did have one question. I'm going to scroll up as well to make sure we get that right. It was basically, if I don't know a lot about, if I'm not familiar with television and tech, how do I become an entertainment technologist if I don't know anything about TV and tech?
Yeah, so one way obviously is, as you learn anything else, first of all, you can go to school for it and decide, you know, I really like the idea of doing this, and I'm going to go to a school that specializes in it. And that was what that URL was. But the other thing you can do is, as I said, you've got a video editor program built into, if you have a PC or a Mac, there's kind of simple editing tools for you to do your own video edits. And you can start there. There are also some free and simple animation software that you can play with if you like to do animation. And just as you would do with anything else that you're interested in, experiment with it. See what you can do. See what works. See what doesn't work. And don't be afraid to make mistakes, because you learn more from your mistakes than you will from your successes. I hope that helped.
That does, Dave. And I believe our keynote speaker today said that same thing. We learn more from our mistakes. We had another question. Would a 3D animator go to an art school, tech school, or a film school?
There are actually 3D animation schools. So,
Wow.
you know, there are the Academy of the Arts in the San Francisco Bay Area. There are, I believe that those are also available on the East Coast. There's some in the Northwest, Seattle type of thing. There's so if you were to search for 3D animation school, it would give you a pretty lengthy list of places that focus just on that. And the types of things that you could specialize in, even within 3D animation, would be either modeling or animation, which is the movement, or algorithmic programming. So like, for example, the hair or water that you see in a lot of animated films, those aren't created by hand, those are created by an algorithm, and those algorithms have to be written to fit the scene that they're made for. So if solving problems like, okay, how am I going to generate mathematically what shimmering water would look like, and what a wave would look like, that's exactly the kind of stuff that people would want in that type of environment. So it can range from someone who can completely be a good artist and draw things, all the way to someone who has never picked up a pen or a paintbrush in their life and just wants to write code with keyboards that can make gorgeous imagery.
Great, Dave. I think we had one other question here. Do artists have to draw out every tiny little process of a movement for the film, or once they create the character in that scene, can they just move it around?
Right, good question. So that's right. The way 3D animation works, and this is a little different than 2D animation, like flat cartoons, or The Simpsons. But in those, like Simpsons are drawn, each scene, each frame is drawn as a relative change from the one before it. So they don't have to draw absolutely everything, but they have to make the little changes. In 3D modeling, you're creating a model. And so you have a character who has certain characteristics. He's, this tall, and he's this heavy, and then you can move him around within the scene. And everything else in the scene is also models. So even the light source can be moved around. Or when he goes through the door is a model. And when he interacts with the door, or when he's walking on the floor, his feet don't go through the floor, because the floor and the model know that they can't pass through each other. So, and that's part of the whole software application that allows the modelers to work in a very efficient and intuitive way. So I would refer to it almost as digital puppeteering. It's more like you're manipulating a puppet than you're manipulating ink or art or pixels.
Great. Dave, we have a follow-up question that I think I'm just going to rephrase a little bit. And basically, the question is, do you have to go to college in order to do this, or are there opportunities if you don't necessarily have a college degree?
Yeah, so a lot of people get into media and entertainment jobs by just diving in, like going to work for a company that happens to be involved in it, either as an intern or as someone just getting in on the ground floor, working as maybe you're working as a junior administrator, or someone who just goes and gets coffee for people, or whatever it happens to be. But by being around it, you're going to find an affinity for what it is you see that you would like to do. And then, if you're not going to go to college, then you just need to ask questions and keep trying to help people and understand that you're interested. And one of the nicest things about the media and entertainment industry is that we're a relatively small industry compared to like healthcare and financial services. And we're all part of a club that wants to help people become part of the club. So you'll find a lot of really welcoming people that want young people to learn how to get involved and how to understand their skills and make the most of them. So look for entry-level jobs at companies where you would like to work. If it was Dreamworks, you go get an entry-level job at Dreamworks. They exist, and or wherever you have someplace nearby you.
Great. Dave, thanks. I don't see any other questions coming in. I don't know if any of the panelists see anything coming in on the other questions. Was there any last or parting thoughts? Or if there was anyone, I'll give them a few seconds. See if you have any other questions. Certainly feel free to drop that in the Q&A. or certainly chat with the panelists, and we'll make sure we get that one answered for you.
Okay, great. No, thank you for thank you for taking time to listen to my pitch, and I hope you enjoyed it. And good luck, and do great things.
Great. Dave, thank you so much, and to all our participants, thank you very much as well. I think we have just a few minutes, about 15, maybe even about 10 minutes or so. I'm sorry to head over to the closing keynote speaker, and then we'll be done for the day. But thanks for hanging in there with us, Dave. Thank you so much from all of us at YWIT, and I'm sure the participants on the line. Thank you so much.
Thank you. Bye-bye.